All right, hello, and welcome back to Chapter 2. We'll be looking at Lesson 8 on solving rational inequalities. And we'll be doing that by what's commonly known as the test point method. And so what they'll do is they'll just have some understanding of just where a function is positive and where a function is negative. And that's what we're explaining in this little area right there. So kind of graphically what we're looking at is, we get a function, and let's just take a regular quadratic, that might be drawn, come down through like this. It might have zeros at 1 and 3. All right. Obviously anything above the x-axis here, that's where our y values are positive, or our function f of x is where it is positive or greater than 0. Where it's below, that's where the value of the function is less than 0, or that's where it's negative. Okay, so in this situation, what we could say is that f of x is positive on this interval from negative infinity all the way up to 1. Okay, so that's where it's all positive here, is up to 1, because it's now where it's below here, that's where it's negative. It doesn't become positive again until after 3, so I unite that with 3 all the way to positive infinity. So again, we use parentheses here because at this point, it's not positive. It's 0. It's equal to 0. So we also know then that f of x is negative. That's where its negative is down here in this part. So that's between 1 and 3. So get a little practice here. If I were to solve this solve this inequality graphically, we could certainly put this in Desmos and graph this. But if I'm looking to see where it's greater than or equal to 0, I'm looking to see where is this positive? Where is this graph positive? And that's all the places that are above this that x-axis. So if you use Desmos and got this, you could find these zeros here. This 0 here is actually negative 4/3 if you type that into Desmos. This one here is negative 1. And this 0 here, it's actually got a multiplicity of 2. It's because it actually bounces there at 2. All right. So if I'm looking to see where is this positive, and it's everything that's above, so it is positive on the following interval from negative infinity all the way up to negative 4/3. Okay. And united with everything here from negative 1 all the way up to 2. And united from everywhere from 2 and above. Now, I'm just realizing here, as I went through this, because we have greater than or equal to 0, we can go back in and change some of these parentheses, because if I'm going to let it to be equal to 0, when it is negative 4/3, that's fine. That's when it is 0. That's actually when it is equal to 0. So I'd actually have a bracket there. And same thing here with the negative 1 and also on the 2's. So unite that with bracket negative 1, bracket to 2, united with bracket 2 to infinity. Because again, we could actually be those values, because we got that little line underneath. That's greater than or equal to 0. All right, let's keep going here. Let's try to have it give a little bit different look. Let's have it in that factored form here, so you can kind of see our equation right here. And what I want to do is it says I want to determine the real number of values of x that cause f of x to be a 0, to be positive, or to be negative. All right. Well, when I look at that function, f of x equals x plus 3 times x minus 4 squared, we can see that we have zeros. If I set this x plus 3 equal to 0, I have a 0 at x equals negative 3. Set that equal to 0 at x equals 4. That's where we'd have another 0. And just as a side note again, this one would have a multiplicity of 2, so in the graph it would actually bounce on that. But what I'm doing here is just to be able to find, these are the zeros. We've got that piece. But we want to find out where that graph is positive or is negative. That's where we can kind of just use this little test point method and look at, there's negative 3, there's positive 4. And then what we'll do is we'll just take a value, a number that's less than negative 3, so we can maybe try like negative 5. Negative 5 is certainly over in this area, and put this back into the equation, into those x's, and see what kind of number we get. So we get negative 5 plus 3, that negative 5 plus 3, and this put negative 5 in there, I get negative 5 minus 4 and square it. Well, negative 5 plus 3 is a negative number. It's negative 2. Negative 5 minus 4 is a negative number, but we've got to square that. So this would actually be a negative number times a negative number squared, which is a positive number. Negative times a positive being negative. So our answers in this area are always going to be negative. So that's where I know I've got an area either from negative infinity up to negative 3 is where I have a negative answer. At negative 3, that's where it is 0. And at 4, that's where it is 0, because we just determined that back here. So let's determine these other areas. Let's look at negative 3 to 4. An easy number to pick might be just the number 0. So if I put 0 into this equation, I get 0 plus 3, which is a positive number. 0 minus 4, which is a negative number, but I got to square that. Squaring a negative number, it makes it positive, so I got a positive times a positive. Every number in here would be positive then, in this area. Let's try this area on the other side of 4. Let's just pick a number like, say, 5. So if I do that, 5 plus 3 is 8. That's a positive number. 5 minus 4 is 1. That's a positive number, and square that. If I square a positive number, I'm always going to get positive. Positive times a positive is a positive. So I know that every number in this area is positive. So to answer the question, so part A, those are our answers right there. Part B, where is it positive? Well, it's positive between negative 3 and 4 on that interval, united with 4 to infinity. So again, it's just where it's positive, so we can't include that because that's where it's 0. For the letter C, where is it negative? Well, it's negative right over here on this side, and that was from negative infinity all the way up to that negative 3. All right, well, let's throw in some radical problems here and look at what happens here. So again, remember, we're trying to remember things that, radicals, okay, we don't want radicals to be negative, okay? So we'll have some limitations on this on this problem. So again, this square root has to be greater than or equal to 0, all right? So just kind of keep that in mind. Okay. So as I look at this graph, I'm going to try to look at where the zeros might be. So I'm going to take this piece right here, this x minus 2, set that equal to 0. Add 2 to both sides, so x equals 2 is a 0. Here, now, this x plus 1 piece, if I look at that inside there, that x plus 1, if I want to find out where that is 0, I subtract 1 to get x equals negative 1. So that's where this would make, because if I put this negative 1 back in there, that'd make that 0, which is fine. I can take the square root of 0, which is 0. It would make this whole side 0. So these are my zeros. So looking at the test point method, I've got a test point here at negative 1. That's where it's 0. And also at 2. And that's where it is also 0. All right. So when we look at this graph now, we're going to take some test points and look at how they work in that equation. So if I take a point here that's less than negative 1, let's just try negative 2. We'll put negative 2 in. So negative 2 minus 2 is negative 4, so I got a negative number. Put negative 2 in there. Negative 2 plus 1 is negative 1. The square root of negative 1, can't do. Can't do. So we're going to say that's undefined. And so really this whole thing over here is undefined. Right, so we're not going to have, it's not above the x-axis or below the x-axis. All right. So let's pick a number between negative 1 and 2. Let's pick 0. If I put 0 in there, 0 minus 2 would be negative 2, so it's a negative number. Put a 0 in here, 0 plus 1 would be 1. Square root of 1 is 1, that's a positive number. Negative times a positive is a negative, so everything in this area is negative. Everything in this area from 2 and above, let's just pick a number there. Let's just pick 3. 3 minus 2 is 1, that's a positive number. Put 3 in there. 3 plus 1 is 4. Square root of 4 is 2, that's a positive number. Positive times a positive is a positive, so I know everything in this area is positive. Well, and that's where I got to look at the question. Question asks, where is it less than or equal to 0? So I know it's equal to 0 here at negative 1 and 2, and it's negative everything in between that. So my solution would be, again, I can include that negative 1 because I want it to be equal to 0. So negative 1 all the way up to 2. And again, include that 2 because I want to find out where it's also equal to 0. So that would be our answer. All right, let's keep practicing. Looking at some different scenarios here to get you enough examples. So when you do get working, you have some resources for you. Yeah, sorry, this is a little blurry here. But that's, if I rewrite that here, this is just an r of x equals x plus 1 all over x plus 3 times x minus 1. So again, the question is asking us to determine the zeros, where it's undefined, where it's positive, and where it's negative. So that undefined piece is coming back into play again. Like that last one, we actually had it undefined in that first area where we couldn't take the square root of a negative number. But we're going to have some undefined areas here as well, too, because we can't have zeros down in the bottom. All right. So I got to look and see where is this undefined. I'm actually going to answer that part of the question first. So I'm going to go to the B part, and I know that I can't. It's undefined. I can't have x be negative 3, and I can't have x be 1 because that would make those both 0. So it's undefined where x is negative 3. And where x is 1. Now, where it's 0, so let's go back to part A here. Where it's 0, well, that's where this answer would be 0. So, in other words, to make this whole fraction 0, I'd have to have that top be 0, because 0 over anything would be 0. So I'm looking to see where x plus 1 equals 0. Subtract x equals negative 1. Is where it's 0. So we'll put that down here. Now where it's positive and where it's negative, again, that's where I'll draw the little test points. And I've got these test points now at where it's 0 and where it's undefined. So if I put them in kind of order here, -3, -1, and 1, I'm going to test these different areas then to see where it's positive and see where it's negative on either side of these either undefined or 0 spots. So if I took a number, say like -5, and put that into our equation here, we'd have -5 plus 1, that'd be a negative number, all over -5 plus 3 is a negative number, -5 minus 1 is a negative number. So continue this out, this would be a negative number over a positive number, which would make it negative. All right. So I know it's negative in this area. Let's take a number here between -3 and -1. Let's take -2. If I put -2 in there, -2 plus 1 is a negative number. -2 plus 3 is a positive number. -2 minus 1 is a negative number. So I'd have a negative over a negative, which would make it positive. So everything in this area is positive. Check this area. If I take and put a 0, 0 is in between there, so I'm going to check 0. So 0 plus 1 is 1, it's a positive number. All over 0 plus 3, which is a positive number. 0 minus 1, which is a negative number. So I'd add positive over a negative, which would be a negative. So everything in here would be a negative answer. And let's see anything over 1. So let's just pick an easy number like 2. 2 plus 1 is 3. That's a positive number. All over 2 plus 3, which is 5. That's a positive number. And then 2 minus 1, which is a positive number. So this is all be just a positive or everything here would be positive. So as I write these answers here, letter C, where is it positive? So it's between, again, not including those spots because that's where it's 0, where it's neither positive nor negative. So between -3 and -1, united with everything that's greater than 1. So 1 to infinity. Letter D, where is it negative? Well, that's from negative infinity all the way up to that -3. It's also negative right here, so unite that with -1 to 1. All right, we're going to give you a little chance to practice now too here, so just make sure we're kind of paying attention to what that inequality is. If it's greater than 0, we're just going to look for where is this positive. All right, so we'll pause the video here, give you a chance to work on your own, and see how you did. All right, and hopefully you're able to come up with this answer down here on the bottom as our solution set for this inequality. So again, I factored this first so I can help identify where those zeros are by looking to see where the numerator, where those factors are 0, and then also identified the undefined pieces as well too, to be able to get the points on the grid down here. Now you notice I made an open circle at 2 because I can't have 2 down here on the bottom, so I don't want to include that. I can have 3 and -4. Those are actually where the zeros are. But now remember, I just wanted to find out where it's positive, so I'm not going to include those in my answers, which is why I've got the parentheses in my answers down here below. So hopefully you're able to check those different segments and identify where it's positive here on these outsides. So we'll do one more practice problem and then turn one more problem for you for guided practice and see how it goes here. So same idea. We're going to look to see where the zeros are, where it's undefined, where it's positive, and where it's negative. So again, I'll draw this or write this out a little bit bigger and so we can all see it and maybe a little clearer as well too. So this is x plus 3 times x minus 5 all over 5x minus 2. So again, what I like to do right away is just look at, okay, where is it undefined? That can't be 0 down there. So we'll go 5x minus 2 equals 0. If I add 2 and divide by 5, you get x equals 2/5. That's where it's undefined. The zeros are going to come from the top here, so we'll say that x plus 3 equals 0, so x equals negative 3 is a 0. And the same thing here with this x minus 5, set that equal to 0, and x equals 5. Those are the zeros. So when I look at making my answers here, the zeros are at x equals negative 3 and x equals 5. It's undefined at x equals 2/5. So those give me the points on the number line that I got to be concerned about. And I can just mark those here. So they're at negative 3. Again, I can make a solid dot on that because that's where it is 0. The 2/5, so I'm just going to arbitrarily just get that right there. That's where it's undefined, so I'm going to make an open circle. And then also here then at 5, let's arbitrarily put that there. And that can be a value. That's where it's 0. So to find out where it's positive and negative, we're going to do those test points here. So I'll take a point here like negative, let's say, this is say, let's go negative 5. Okay. Negative 5 plus 3, that's a negative number. Negative 5 minus 5, well, that's negative 10, that's a negative number. And then here, negative 5 times 5 would be negative 25, minus 2 would be negative 27, that's a negative number as well. So negative over negative, or negative times negative is a positive over a negative, which will make this all negative. Here, and this easy number to pick is 0. So I put 0 in there. 0 plus 3 is positive. 0 minus 5 is negative. And I put 0 in here, that'd be minus 2, which would be a negative. So together this would be a negative over a negative, which is a positive. So everything in here would be positive. Pick a number here. Let's just say 1. That's kind of an easy one. 1 plus 3 is a positive number. 1 minus 5 is a negative number. 1 times 5 is 5 minus 2 is a positive number. So this would be a negative over a positive, which overall is a negative answer. All right. Last one here, let's just pick a number like 6. That's bigger than that. So 6 plus 3 is 9. That's a positive number. 6 minus 5 is 1. That's a positive number. And then 6 times 5 is 30. Minus 2 is 28. That's a positive number. So everything's positive here, so this is positive. So letter C, where is it positive? Well, between negative 3 and 2/5. Again, you'll notice I'm not including any of these because I'm just looking for where it's positive. Because this is where it's 0. This is where it's undefined, so I've got just parentheses on both of these. United with 5 and above. Letter D was where was it negative? So I'd say from negative infinity all the way here up to negative 3. Again, use parentheses because I'm just looking at the negative piece, not whether it's equal to 0 or undefined. And same thing here, united with from 2/5 all the way up to 5. Okay, so I'll give you one last complicated one here to try on your own and have you pause the video, see how you did, and when we come back with the answers. All right, and hopefully you came up with this as our interval solution for our answers. Again, making sure that you did address this idea that, again, it was positive or 0 because it's greater than or equal to. So when it is a 0, we can include that value there as well too. So from 3 to 4 and 4 and beyond, again, you can't have 4 because that was an undefined value. So we got our interval from 3 to 4 and 4 to infinity, making sure we're getting the proper parentheses or brackets. So here we go. We'll give you a little chance to practice with your homework with section 2.8, and wish you good skill in your work. Thanks, everybody.